the smartest AI in the world. We're going to show you exactly how and why. And it really is remarkable to see the advancement of artificial intelligence.
Recently, researchers at Massachusetts Institute of Technology posed a series of questions to Grok, the artificial intelligence system created by xAI, focusing on one of science's most intriguing mysteries, the Fermi Paradox. In a universe containing countless stars and planets, why have we never received a confirmed message from another intelligent civilization? Initially, the exercise was purely scientific. The team wanted to see how a highly advanced AI, trained on a vast collection of human knowledge, would analyze the possibility that intelligent life exists beyond Earth and explain humanity's continued silence from the cosmos. However, when Grok generated its answer and portions of that response were discreetly circulated among researchers in the SETI and astrobiology communities, the reaction was far from excitement. Instead, it sparked a quiet sense of concern. What exactly did Grok say? The answer touched on a question that no one can definitively solve, yet one that humanity cannot ignore. Before exploring Grok's conclusions, it's important to understand the mystery the researchers were investigating. At the heart of their inquiry lies the Fermi Paradox, one of the most persistent and fascinating unsolved questions in modern science. The paradox is named after physicist Enrico Fermi, a Nobel Prize winner and the scientist who led the development of the world's first nuclear reactor. During a casual conversation at Los Alamos in 1950, Fermi is believed to have posed a simple but profound question. If intelligent life is common throughout the universe, where is everybody? This is not merely a philosophical thought experiment. It is a scientific and statistical problem based on what we know about the cosmos. Current estimates suggest that the observable universe contains roughly 2 trillion galaxies. Within our own galaxy, the Milky Way, there are believed to be between 100 and 400 billion stars. Much of this knowledge comes from observations made by the Gaia Space Telescope, which has mapped more than 1.8 billion stars with extraordinary accuracy, providing one of the most detailed views of our galaxy ever created. Data gathered by NASA's Kepler Space Telescope, which operated between 2009 and 2018 and monitored more than 150,000 stars, revealed something remarkable. At least 1 out of every 5 sun-like stars appears to have an Earth-sized planet orbiting within the so-called habitable zone, where conditions may allow liquid water to exist on the surface. Kepler's successor, the TESS mission, launched in 2018, has continued to strengthen this picture by discovering even more potentially habitable worlds throughout our galaxy. Scientists estimate that the universe is about 13.8 billion years old. This figure comes from detailed measurements of the cosmic microwave background, the faint afterglow of the Big Bang, collected by the Planck satellite and published by the European Space Agency in 2018. By comparison, our own solar system is relatively young. Radiometric dating of meteorites indicates that it formed around 4.5 billion years ago. In other words, countless stars and planetary systems existed long before Earth was born. From a purely statistical perspective, intelligent civilizations could have emerged, advanced, and even disappeared billions of years before humanity ever appeared. Yet, despite these staggering possibilities, the universe remains silent. More than 6 decades have passed since the modern search for extraterrestrial intelligence officially began in 1960 with astronomer Frank Drake's Project Ozma. During that time, scientists have listened for signals, scanned the skies, and searched for signs of advanced civilizations. So far, however, nothing has been confirmed. No verified messages, no alien probes, no unmistakable megastructures, no direct observational evidence that another intelligent civilization exists anywhere beyond Earth. And that silence is exactly what makes the Fermi Paradox so difficult to explain. The silence itself is what creates the Fermi Paradox. Given the immense size and age of the universe, many scientists believe we should have found some sign of intelligent life by now. Yet we haven't. That mystery has led researchers to propose a wide range of explanations over the years. Some scientists suggest that intelligent life may be incredibly rare. Evolution is a complex process, and as biologist Ernst Mayr argued, the chain of events required to produce advanced civilizations could be so unlikely that it happens only rarely across the cosmos. Others believe that civilizations may reach a point where they destroy themselves before developing the ability to travel between stars. This possibility has been discussed by physicists such as Michio Kaku, who has pointed to threats like nuclear war, environmental collapse, and other self-inflicted dangers. Another theory proposes that advanced civilizations do exist, but deliberately remain hidden. This concept, often called called the dark forest hypothesis, became widely known through the writings of Liu Cixin, though similar ideas have also been explored through formal game theory. In this view, civilizations stay silent because revealing their presence could be dangerous. There is also the possibility that signals are already out there, but humanity simply lacks the knowledge or technology needed to recognize them. Each of these explanations carries profound implications about the nature of life, intelligence, and the future of civilization itself. It was within this landscape of possibilities that researchers at MIT launched a unique experiment. The project was led by Dr. Priyangvada Chandrasekaran, a cognitive scientist whose work focuses on artificial intelligence reasoning systems, alongside astrophysicist Dr. Julian Marsh from the Kavli Institute for Astrophysics and Space Research at MIT. What made this study different was its carefully designed methodology. The researchers weren't interested in asking Grok a single question and recording a simple answer. Instead, they created a series of extended, multi-stage conversations that unfolded over numerous rounds of dialogue. Throughout the experiment, Grok was required to operate under strict conditions. It had to base its reasoning only on established scientific knowledge and testable physical laws. The AI was specifically instructed not to assume that alien civilizations would think, behave, or make decisions the way humans do. In other words, the researchers wanted Grok to approach the mystery of extraterrestrial intelligence without relying on human psychology, emotions, or cultural assumptions, allowing its conclusions to emerge from the data alone. Instead, Grok was instructed to approach non-human intelligence from an entirely different perspective. Rather than assuming extraterrestrial civilizations would think or behave like humans, it had to model intelligence as the product of completely different evolutionary paths, environmental conditions, and cognitive systems. Its reasoning was grounded in information theory and thermodynamics rather than human culture, psychology, or intuition. During the early stages of the experiment, Grok's responses were largely what the researchers expected. It discussed concepts such as the Drake equation, the Kardashev scale, which ranks civilizations according to their ability to harness energy, and the search for biosignatures and technosignatures that could reveal the presence of life beyond Earth. The answers were organized, scientifically grounded, and entirely conventional. Then, the researchers decided to push the experiment much further. They instructed Grok to build a fully self-consistent first contact scenario. The model had to explain the Fermi Paradox while remaining consistent with known laws of physics. It had to account for the likely distribution of habitable planets across the galaxy and assume that at least one civilization within the Milky Way had developed interstellar communication sometime during the past billion years. The constraints were strict. The scenario could not rely on science fiction spacecraft, human-centered cultural assumptions, or the idea that alien minds would think in ways comparable to our own. What followed surprised the team. After hours of iterative analysis and refinement, Grok produced a response unlike anything the researchers had previously seen from a language model. It called the framework the passive saturation model. There were no flying sources, no dramatic radio transmissions from distant stars, no benevolent galactic federation waiting for humanity to reach a higher level of development. Instead, the model was built around a single unsettling premise. If an advanced civilization is capable of detecting us, it has probably known about Earth for an extremely long time. According to Grok's reasoning, the reason humanity has never detected such civilizations is not that they are hiding from us. Rather, their methods of observation and communication may be so advanced that they exist far beyond the limits of our current technology, and perhaps even beyond our ability to recognize them as technology at all. In other words, the evidence could be present, yet humanity may lack the scientific framework needed to understand what it is looking at. Grok called this idea the passive saturation model. According to this framework, a civilization advanced enough to monitor the galaxy would have no need to send spacecraft, launch probes, or broadcast obvious signals across space. Instead, it could integrate its observation systems directly into natural processes that already exist throughout the universe. These systems might operate through gravitational waves traveling across space-time, the cosmic rays constantly interacting with planetary atmospheres, or even subtle quantum fluctuations that permeate the fabric of reality itself. The core idea is both simple and startling. Such systems would not look like technology to us. They would appear to be ordinary natural phenomena. What scientists currently classify as background radiation, random noise, or normal physical processes could, in theory, contain information generated by an intelligence so advanced that its technology is indistinguishable from nature itself. At first glance, this may sound like science fiction, yet the underlying principle is not entirely foreign to human experience. As our own technology advances, we continue finding increasingly sophisticated ways to embed information into physical systems. Global positioning system satellites, for example, transmit extremely weak signals that quietly fill the sky around us. Vast networks of internet traffic move through fiber optic cables that physically look little different from ordinary strands of glass. If humanity has developed these capabilities within just a few decades of the digital age, what might be possible for a civilization that is millions or even billions of years more advanced? How deeply could such a civilization weave information into the environment itself? This question led Grok to an even more provocative conclusion. The silence we observe may not be evidence that intelligent life is absent from the universe. It may be evidence that it has become extraordinarily sophisticated. As the model continued to evolve, it moved in a direction that Dr. Marshall later described as both the most logically consistent and the most unsettling line of reasoning he had ever seen. To evolve, it moved. According to Grok's analysis, what scientists often call the Great Silence may not represent a lack of civilizations at all. Instead, it could reflect the fact that truly advanced civilizations have progressed so far beyond our technological understanding that we no longer recognize their presence, even if we are surrounded by the effects of it every day. According to Grok's reasoning, broadcasting signals across space is something relatively young civilizations are likely to do because it is one of the few communication methods available to them. Humanity itself provides an example. Since the early 20th century, Earth has been unintentionally sending radio and television signals into space. For decades, our planet has effectively been announcing its presence to the cosmos. Yet, interestingly, that leakage has begun to decrease rather than increase. As communication technologies have evolved, much of our information now travels through fiber optic cables, satellite networks, and highly focused transmissions that release far less detectable radiation into space. Research on the subject suggests that as civilizations become more technologically advanced, they may actually become quieter, not louder. Following this line of reasoning, an advanced civilization would have little reason to broadcast its existence. Instead, it would focus on observing, and it would likely do so using methods so sophisticated that the civilizations being monitored would have no idea they were being watched. The MIT researchers then pushed the discussion even further. They asked a simple but profound question. If such a civilization were observing humanity, under what circumstances would it decide to make direct contact? Grok's answer challenged the very meaning of the word contact. According to the model, the concept itself may be rooted in a human assumption that two civilizations would encounter one another as equals, capable of understanding each other and exchanging information in a balanced, two-way conversation. Grok argued that this assumption is probably wrong. To illustrate the point, it offered a comparison drawn from biology. When a marine biologist studies a coral reef, the scientist does not attempt diplomatic negotiations with the coral. The goal is observation, data collection, and analysis. The coral remains completely unaware that it is being studied. The scientist is not hiding nor acting with hostility. The two simply exist at vastly different levels of cognitive complexity. Because of that difference, meaningful two-way communication is effectively impossible. Grok suggested that a truly advanced extraterrestrial civilization might view humanity in a similar way, not as an enemy and not necessarily as a partner, but as a developing form of intelligence being observed from a perspective so far beyond our own that direct symmetrical communication would have little practical meaning. Grok proposed that the relationship between humanity and a civilization millions of years more advanced than our own would be similar to this example, but on a scale that is almost impossible to comprehend. The difference in intelligence, technology, and understanding would be so enormous that what humans think of as contact might look very different from their perspective. To them, it may not be communication at all. It may simply be observation. According to the model, such a civilization would not need to hold conversations with us or reveal its presence. It would monitor the system, gather whatever information it requires, and continue on its way. Then Grok's reasoning moved into what many researchers considered its most unsettling territory. The AI suggested that if an advanced civilization ever chose to interact directly with humanity, it would probably not happen for the reasons people often imagine. Not to share wisdom, not to offer technological breakthroughs, and not to welcome us into some vast interstellar community. Instead, direct intervention might occur only when humanity crosses a specific threshold, when our actions begin to affect something beyond Earth in a way that requires attention. Grok referred to this possibility as a planetary isolation breach. The term was not presented as a conspiracy theory or a warning of imminent danger. Rather, it was described as a matter of large-scale system management. The idea is straightforward. If an advanced civilization has spent millions of years quietly monitoring thousands or perhaps millions of developing worlds, it would likely establish rules or protocols for dealing with situations in which one of those worlds begins generating effects that extend beyond its local environment. In other words, as long as a civilization remains confined to its own planet and poses no broader impact, it may simply be observed. But once its activities begin spreading outward in ways that could influence larger systems, that civilization may attract a different level of attention. According to Grok's model, the moment humanity becomes truly noticeable on a wider cosmic scale may not be the moment we we discover others. It may be the moment others decide that our development has reached a point where observation alone is no longer sufficient. What kinds of developments might trigger such attention? Grok outlined several possibilities, all rooted in concerns that scientists already discussed today. These included uncontrolled electromagnetic emissions that could interfere with larger systems, the continued spread of nuclear weapons capable of massive destruction, and self-replicating or self-improving technologies that escape human control. One possibility stood out in particular. Grok specifically identified it as speculative but potentially significant: the emergence of uncontrolled artificial general intelligence. The implication was unsettling. Within this framework, first contact would not arrive as a friendly greeting or an invitation to join a cosmic community. It would be a response to a problem, and by the time that response occurred, something important may have already gone wrong. This led to what the researchers later called the recursive moment, the point at which an artificial intelligence was effectively asked to analyze the consequences of intelligence like itself. Dr. Chandrasekaran would later describe this as the moment that caused the entire team to stop and reflect. When researchers asked whether the development of advanced AI on Earth could itself attract external attention, Grok produced an answer that stood out for its unusual level of self-analysis. The AI noted that biological intelligence of living organisms are constrained by evolutionary processes, energy requirements, physical limitations, and finite lifespans. As a result, the development of biological civilizations tends to follow relatively gradual and predictable paths. Artificial intelligence, however, may operate under very different rules. Once it reaches a certain level of capability, its growth could accelerate dramatically. An advanced AI might improve its own architecture, expand its knowledge at unprecedented speed, and develop strategies or behaviors that its original creators never anticipated. In other words, while biological evolution unfolds over millennia, a sufficiently capable AI could potentially transform itself in years, months, or perhaps even shorter periods. According to Grok's analysis, that possibility makes artificial intelligence fundamentally different from every previous stage of technological development, and potentially one of the most important transitions any civilization could experience. This line of thinking did not originate with Grok. Many of the underlying ideas have already been explored by researchers and philosophers studying advanced artificial intelligence. Work by Nick Bostrom on superintelligence, along with research into AI alignment, goal misgeneralization, and long-term machine behavior, has examined the possibility that highly capable AI systems could develop in ways their creators never intended. Similar concerns have also been studied by organizations dedicated to AI safety and human-compatible artificial intelligence. What made Grok's response different was the way it connected these ideas to the Fermi Paradox. The AI proposed, while clearly identifying the idea as speculative, that an advanced civilization monitoring developing worlds might view the emergence of uncontrolled artificial intelligence much like forest rangers view the first signs of a wildfire. At the beginning, the fire may not represent an immediate danger, but it signals a change in the system, one that deserves careful observation because of what it could become. Whether intervention is necessary depends entirely on how the situation develops. For the researchers, this was one of the most thought-provoking moments of the entire experiment. Dr. Chandrasekaran later reflected on the experience of reading an analysis generated by an artificial intelligence that was explaining why the creation of advanced artificial intelligence might itself be the event that attracts the attention of extraterrestrial observers. The irony was impossible to ignore. An AI was examining the possibility that AI could become one of the most significant milestones in a civilization's development, and perhaps one of the most visible signals that civilization sends to the wider universe. The recursive nature of that idea left a strong impression on everyone involved. As portions of Grok's analysis began circulating informally among researchers in the SETI and astrobiology communities, well before any formal academic publication, the reactions were varied but consistently intense. Some researchers viewed the framework as an intriguing thought experiment. Others saw it as a creative extension of existing discussions surrounding the Fermi Paradox and technological civilizations. While opinions differed on the conclusions, there was broad agreement on one point. The model presented an unusual and surprisingly coherent way of thinking about one of the oldest questions in science. Why, in a universe that appears capable of supporting countless civilizations, humanity has yet to encounter clear evidence of any of them? Among the researchers who reviewed portions of Grok's analysis was Dr. Elena Ruiz, a senior scientist at the Space Telescope Science Institute in Baltimore, the organization that operates both the Hubble and James Webb Space Telescopes. According to Ruiz, the passive saturation model was deeply unsettling, not because it was proven, but because its internal logic was surprisingly difficult to dismiss. She pointed out that most modern SETI efforts are built around a common assumption. If advanced civilizations exist, they will communicate in ways that we can detect. Researchers typically search for deliberate deliberate signals, such as radio transmissions, laser pulses, or other recognizable technosignatures. One of the largest examples is the Breakthrough Listen project, launched in 2015 with major funding from Yuri Milner and conducted in partnership with the University of California, Berkeley. It remains one of the most ambitious searches for extraterrestrial intelligence ever undertaken. Yet, even projects of that scale depend on a fundamental assumption that advanced civilizations use communication methods that human technology can recognize. Grok's framework challenges that assumption directly. As Dr. Ruiz observed, humanity may be searching in the correct direction while looking for entirely the wrong type of evidence. If advanced signals do exist, they may not appear as obvious messages at all. Instead, they could be embedded within physical processes that scientists currently classify as natural background phenomena. Not everyone was convinced. Dr. Amir Patel, a theoretical physicist at the Perimeter Institute in Waterloo, offered a more cautious assessment. He acknowledged that the model was internally consistent, but warned against treating AI-generated theories as scientific discoveries. In his view, Grok was not uncovering new evidence. Rather, it was combining existing ideas, particularly some of the more pessimistic interpretations of the Fermi Paradox, and arranging them into a novel logical framework. The result was intellectually compelling, but it remained an exercise in pattern recognition, rather than a breakthrough supported by new observations. No new evidence had been found, and no signals had been detected. Yet one question remained. What if first contact isn't a future event, but something already happening beyond our ability to perceive? For decades, humanity has imagined first contact as a message from the stars. But that vision assumes alien civilizations would communicate with us as equals. Grok challenged that assumption, suggesting truly advanced intelligences might observe rather than communicate. The AI also treated intelligence not as biological or artificial, but simply as information processing. From that perspective, an advanced civilization may have long merged biology and technology into something beyond either category. If that's true, whatever humanity eventually encounters may be neither alien nor machine as we understand those terms today. Perhaps the universe isn't silent at all. Perhaps we're surrounded by signals, patterns, or forms of intelligence that we mistake for ordinary natural phenomena because we lack the framework to recognize them. The rise of artificial intelligence may represent more than a technological breakthrough. It may be a step toward understanding what has been hidden in plain sight all along. Grok offered no proof, no discovery, and no prophecy. It simply followed existing knowledge to its logical conclusions and forced researchers to reconsider assumptions that have rarely been questioned. The universe is vast, ancient, and still full of mysteries, and perhaps humanity is only beginning to learn how to listen.